Hello Precalc students, we are in Unit 8 and we're doing our Day 1 notes using properties of logarithms. This is page 2 of your notes. So we're going to start off by using your power property to take these coefficients and make them exponents. So the 1/2 will go to the x, and the 1/3 will go to the y, and the 2 will go to the z. So I'm going to have log of x to the 1/2 plus log y to the 1/3 minus log of z squared. And then we can use your product property to say that the sum of these two logarithms can be rewritten as the log of the product. So that would be the log of x to the 1/2, y to the 1/3. And then we can use your quotient property to show that the logarithm of x to the 1/2, y to the 1/3 minus the log of z squared can become the log of the quotients of those two inputs. So I will have log, and on the numerator, x to the 1/2, y to the 1/3, and in your denominator will be z squared. All right, the next one has some parentheses, so you should deal with what's in the parentheses first. You have a 2, which can become an exponent on the t, and you also have a sum here, so you can be writing this as the log of the product. So I'm going to have log base 5 y minus 4 parentheses, and I'm going to combine this using both the power property and the product property to be log base 5 r times t squared. Okay, so then the 4 can become an exponent out here. So let's see, I'll have log base 5y minus log base 5, and I've got rt squared, and that's all being raised to the 4th power. So then you're using exponent properties to show this will become r to the 4th times t to the 8th. So log base 5y minus log base 5 r to the 4th t to the 8th. And now you can use your quotient property to show that these two can be combined to be the log of the quotient of those two inputs. So I have log base 5, y in your numerator, r to the 4, t to the 8 in your denominator. All right, in the last one, again, we have parentheses, so we're going to start with that. This time our base is x. The properties work no matter what the base is, as long as they all have the same base. So I have a 1/2, and I'm going to combine these with the product property. So it's going to become log base x 4y minus 3 log base x z. And then my coefficients, they can become exponents. So I'll have log base x 4y to the 1/2 power minus log base x z to the 3rd. And this 1/2 can distribute to each of these. So I'm going to have log base x. Now 4 to the 1/2 means square root of 4, and that is 2. But this 2, a lot of people are going to think that you multiply the 1/2 by 4. That doesn't happen. It's the square root of 4, which is 2. And I also have y to the 1/2. And I have minus log base x z to the 3rd. And then use your quotient rule to make this a division. So it's going to be a single log base x. And then we have the quotient of 2 y to the 1/2 over z to the 3. Now, if you need a refresher on those rules, you might want to go back to the first video to see the rules that we put together to make this happen. All right, so here we condensed. We took a long phrase and we put it into a single logarithm. Now, down here we have a single logarithm and we're going to expand it into a longer phrase. So we have the logarithm of a product. I'm going to change that to be log base 5 plus log, I'm sorry, it's not log base 5, it's log base 10 because there's no base there, but it's log of 5 plus log of x to the negative 5, and then you can use your power property to move the negative 5 out front, so you'll have log 5 minus 5 log x. Okay, the next one. Let's see, I have a quotient here, so I'm going to take that part first. So I have log 2 x squared y minus log 3k to the third. And these are all being multiplied, so I can split each one into a separate logarithm, and I can add those logarithms together using, which of the properties is that one? Using your product property. So be log 2 plus log x squared plus log y minus, and I'm going to put parentheses to keep all this together, log 3 plus log k to the third. Okay, so my exponents can move to the front, and this minus is going to distribute to both terms. So this one stays log 2 plus, this exponent goes to the front, 2 log x plus log y minus log 3, and that minus distributes to this term, minus, and then that 3 can come in front, so 3 log k. Okay. So if you're trying number 12 on your own, the only thing you want to keep in mind is that this square root here can be written as a 1/2 power, but because of the minus here, it does not distribute to each term. So this x squared minus 4 will be stuck together there. I'm kind of out of space to do this problem right here, so I'm going to add in a new page, and I'm going to do this on the next page. Okay, so here's my problem. Number 12, log square root x squared minus 4 over x plus 3 squared. So the first thing I see is I see that quotient, so I'm going to break it into log of the numerator minus log of the denominator. And then I said I'm going to rewrite the square root as a 1/2 power. So log of x squared minus 4 to the 1/2 power. And then I'll bring my exponents to the front. So 1/2 log x squared minus 4 minus, that's a 2 there, so 2 log x plus 3. Now, if you remember difference of squares, you know that you could factor x squared minus 4, and then you're going to have the product of two factors, so you'll be able to use the product rule again. So if I break this piece here up into x plus 2 and x minus 2, bring everything else down, so I have 1/2 the log of x plus 2x minus 2 minus 2 log of x plus 3. Then I can use my product rule here to break this into 1/2 log x plus 2 plus, I also have 1/2 log x minus 2, and then minus 2 log x plus 3. All right, going to go back to the previous page. Alright, so here we're going to use our calculator to evaluate common logs. Common logs are base 10. And when you write a common log, you don't put the base there. The base is 10, but you don't write it. So, not used to seeing it there. And you can type this in your calculator and you can get an answer. And the answer that you're finding is 10 to what exponent would give me 50? Well, I know it's bigger than 1 because 10 to the 1 is 10, and I know it's smaller than 2 because 10 to the 2 would be 100. So I'm expecting an answer between 1 and 2, and I'm going to type it in. So the log button is right here. That means log base 10, and I'm typing the log of 50, and I get 1.69, and I'll round that 8 up to a 9 because of the following number, so 1.699. Alright, this one I can use a calculator for too, but I think I know what the answer is, because remember, I'm trying to find out 10 to what exponent would give me 10,000. Alright, so 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000. But just to make sure my calculator is working right, I'm going to do log of 10,000. Yep, so I also get 4 from the calculator. Now, some newer calculators can do a log with a different base that's not 10, but my older calculator can't, and so for that reason I could use the change of base formula. So the change of base formula is if I want to do, for example, log base 2 of 7. I'm saying 2 to what exponent gives me 7. That is not going to be an integer answer. 2 to the 3 is 8, that's too big. 2 to the 2 is 4, that's too small. So I want to type this in my calculator, but my calculator, the only log button, actually there are 2 log buttons. One is log base 10, and the other one is ln, which is log base e, but I don't have log base 2 on there. So I'm going to use the change of base formula, and I'm going to change the base to 10. So I have log base c, that's just going to be log base 10. And this number here, the input of your logarithm, that goes on the top. On the bottom, I'm going to have another logarithm, and it's still base 10, but then this base of my previous log, that goes here. So this is what I would type in my calculator to find log base 2, 7. So let's try that. I'm going to do log 7 divided by log 2. And I get 2.807. Okay, so when you see a problem like this, you might be given a calculator for it, or you might not be. In this case, we're going to try to do this problem without a calculator. So remember, you can put an equals x after it, and then rewrite that one as an exponential. So the base of your exponential is the same as the base of the log. The answer to your log is your exponent, and your input is the answer to your exponential. So you rewrite it as 27 to the x equals 81, and then if you can make those powers of a smaller base, that can help you. So I can rewrite 27 as 3 to the 3, and I can write 81 as 3 to the 4, and remember, if you have a power to a power, you multiply your exponent. So I have 3 to the 3x equals 3 to the 4, and then your exponents, you mark them equal. So you have 3x equals 4, and divide by both sides by 3, and you get x is equal to 4/3. Alright, so this is how you can sometimes solve a logarithm without a calculator. This problem can be done without a calculator. We'll try it also with a calculator. So method 1, no calculator. I'm going to write equals x after it. I have 4 to the x equals 32. Make them both powers of a smaller base, so I'm going to use 2. 2 squared, and let's see, 2 to the 3rd is 8, 2 to the 4 is 16, so this is 2 to the 5, so I'm going to have 2x equals 5, and x is equal to 5/2. Now if I want to do the same problem with a calculator, I'm going to rewrite this as the log base 10 of 32 over the log base 10 of 4. Log base 10 of 32 over the log base 10 of 4. And you're going to put that in your calculator. Log 32 divided by log 4. And I get 2.5, which is the same as 5/2. That's what I got before. Sometimes you get a problem like this. 4 to the x is equal to 18. And that you can't solve that. Even if I change this base to 2, there's no power of 2 that's going to give you 18. So then you have to do your change of base formula. So the change of base formula, I'm going to do log base 10, 18, divided by log base 10, 4. And that will tell me 4 to what exponent gives me 18. I'm expecting it to be a little bit more than 2, because 4 squared is 16. So I'm going to do log 18 divided by log 4. And I'm going to get 2, oops, I went away, 2.085. Oh, it says round to 3 sig figs, which is different from 3 decimal places. 3 sig figs would be 2.0, oh, I don't know what that digit actually was. It would actually be 2.08, because that digit there was a 4. Okay. All right, so that's the end of your notes for today. Make sure you do your homework assignment. Thank you.